Okay, the first 6, 7 questions are basically like 20-second graphing questions. So that each has 2 parts, but each part should take about 20 seconds if you know what you're doing, okay? So attempt question number 1 yourselves. So it says graph that. So that's a cube graph, okay? But we'll do transformations. Shifted 1 unit to the right, and then the cube graph, the parent function shifted 3 units down. So see if this comes back. That's your critical point. It's a regular graph. That's positive too. There's no negative sign there. So it's a regular cube graph that looks like a snake up graph, okay? Let's do the second one. You can pause the video. So that's a square root graph, shifted 3 units to the left of the parent function, 1 unit up, okay? That's a square root graph. So think of the shape. It's a shooting star, but it's flipped, okay? It's not regular, but flipped. So see if your final graph looks like that. Okay, let's do question number 2. You can pause the video. That's an absolute value function, shifted 2 units to the right, 1 unit down. Is it regular or flipped? It's regular, so it's just a simple V-shaped graph, okay? Let's do the second one. In case you've forgotten, that guy is the same as cube root of x, so that's actually the cube root graph. Okay, think of the shape. Shifted, is it shifted left or right at all? No, because there's nothing here in parentheses, okay? So there's no horizontal shift, but we're shifting it 3 units up from the parent function. Regular or flipped? This guy is positive, so regular. And then recall the shape, it's an S-shaped graph, okay? Let's go to number 3. So in case you're not familiar with the log graph, the parent graph looks like this. You can sketch it for your notes. So y equals lmx looks like that. That's your parent function. It has what is called a vertical asymptote, okay? So we just shifted 1 unit to the left, okay? So the vertical asymptote goes here. And it's just a regular graph. So it just goes like that. Okay, let's do the next one. Here, you may be confused because you have 2 letters on the right-hand side, but A is actually a constant, and they're giving you information. They say A lies between 0 and 1. So in other words, it's like a fraction. So you could say 0.5 or 1/2. So that's an exponential function. So is it exponential growth or decay? Keep that in mind. The answer is decay, because that's a fraction between 0 and 1. And then it's shifted 1 unit up. So you have what is called a horizontal asymptote. It's shifted 1 unit up. And that's a regular exponential decay graph. So final graph looks like this. Okay, it's falling. See if that comes back. Okay, let's do 4. You can pause the video. So that's also, as we did before, a cube root graph. So it's like t minus 2 to the power 1/3. But the shape remains the same. Shifted 2 units to the right, 4 units up. So there's your critical point. Regular or flipped? Flipped. And then think of the shape. It's an S-shaped graph, but flipped. So it'll actually look like that. Okay. Let's do the second one. So it says x plus 3 square. So what does that look like? So it's a parabola. Okay. Shifted 3 units left, 2 units down. So there's your critical point. Now, is it regular or flipped? They just say A outside. Look at the information given. Whoa, they say A is less than 0. That makes it negative. Therefore, it's going downwards. Okay? So please be alive to the information given. Okay, let's do 5. You can pause the video, attempt it yourselves. In case you've forgotten, the base function looks like, the parent function is 1 over x. It has a shape like this, that, and like that, okay? So we just need to shift it. So it has a vertical asymptote and a horizontal asymptote. So we need to shift the parent function 3 units to the right. So it has a vertical asymptote here, and shift the parent function 1 unit down. So it has a horizontal asymptote here. So that's your new origin in a manner of speaking. And then positive 5 says it's just a regular graph. Okay, so that's, make sure it's approaching the asymptote. Okay, let's try this guy. Don't get alarmed that the y is on the right side. Okay, it just functions as x. All right, is it exponential growth or decay? It just says ey, so that makes it growth. Okay, and then shifts it 3 units up. Okay, so you have a horizontal asymptote, shifted 3 units up, and then the growth graph kind of looks like that. Okay, but is it regular or flipped? The negative sign says it's flipped about this horizontal asymptote, so the final graph will look like that. Okay, so g of y. Okay, let's do 6. Okay, that's an exponential function again. Look at this base. It says 5/3. So is that growth or decay? In case you've forgotten, if that base is bigger than 1, okay, that's a positive x. If that base is bigger than 1, it's growth. Okay, so think of the exponential growth graph. Shifted 4 units up. So that's your new horizontal asymptote. Exponential functions have a horizontal asymptote, and it's just regular. Okay, so that's your growth graph. The last graph, don't get alarmed by the letter being s, it's just like x. Now the parent function, in case you've forgotten, is like 1 over x squared. And the parent function looks like this. Okay, it's like a volcano. So shifted 2 units to the left. So it has a vertical asymptote and horizontal asymptote. So this is your new vertical asymptote. And shifted 5 units down, 2, 3, 4, 5. So this is your new origin in a manner of speaking. Regular or flipped? Flipped. So final graph looks like this. Okay, like that. Okay, I'm kind of running out of room. Okay. All right. You can pause the video, attempt 7 yourselves. So the first thing we'll do is we'll rewrite it because it's a division operation. So we'll multiply by the reciprocal, 6z squared over x4y2. The way I do it is I just go horizontally first. Simplify yourselves. So you can take the 6 outside. X is by itself. Z3, Z2 becomes Z5. We add powers. 16 stays 16. And then X3, X4 becomes X7. You add powers. We're going horizontally. And then Y2. And then finally, can we simplify the fraction? 2 goes 3 times. 2 goes 8 times. And then I have a X over X7. What do I write and where? So you kind of subtract and you write it with the bigger guy. So it's x6. 7 minus 1, there's a 1 here, 6. And then z5 just comes there, and then y2. Okay, see, we got that. Let's do 8 together. You can pause the video and attempt it yourselves. So it's what is called a rational expression. So on the top, we'll kind of take LCMs, all right? Do not forget the bottom. The bottom is 3x minus 12. By the way, what can I do with the bottom? 3x minus 12. You take out a 3, so that becomes x minus 4, so factor. On the top, you have an x and an 8, so what's your LCM? So that's 8x, so you can multiply by 8, and then x and x. So it becomes 16 minus x squared. Okay, we're not done. So we're dividing fractions, so it can multiply by the reciprocal. I'll do another thing. Can I read this in standard form? So it's like negative x squared plus 16 over 8x times 1 over 3x minus 4. Slow and steady. Observe your algebra. And then over here, what could I do? Good habits. You can take out a negative. So become x squared minus 16 over 8x, 1 over 3x minus 4. Okay. Is there anything else I can do? Yeah, I can. I can factor that. Isn't that difference of squares? So I can do like square root. So it's x minus 4, x plus 4 over 8x, and then I have a 3x minus 4. Can I cancel that? So your absolute final answer really is negative, don't forget the negative, parentheses, x plus 4 all over 8x. Look over that problem again, please. So we were dividing rational expressions. So I took LCMs on top, I factored the bottom, multiplied by the reciprocal, and then simplified, okay? Let's do 9 together. You can pause the video, attempt it yourselves. So what can I do very first step? I can do two things. First, I can get rid of that 2, okay? So I can multiply by 1/2. I can also write the radical a as a 1/2, okay? So play along. And then 10 times 1/2, okay? Or I can just divide by 2, same thing, yeah? So it becomes a, and then what's a2 over a 1/2? Exponent rules. Should we subtract fractions? Or rather, subtract. And then can I use the fraction trick? So that becomes, 2 times 2, 4 minus 1, 3/2. And on the right side, it'll become 5, correct? And then absolute last step. What should I do both sides? I want to get rid of that 3/2. Okay. The key step, in case you've forgotten, is you raise to the reciprocal power. So it's 2/3, like that. Show the step on both sides. So final answer is 5 to the power of 2/3. If that was a nice number, that as in it was a cube of a number, then you can actually simplify further. But right now, just leave this alone. So the final answer is 5 to the power of 2/3. So go over the steps again. So we divided by 2 both sides, and then I rewrote radical a as a 1/2, so I can use use exponent rules. Okay, let's do 10 together. So I'll show you 2 ways to do this. Okay, you can make 2 branches. First, attempt it yourself. So you can pause the video. So method 1 is, I observe that 125 can be written as a power of 5. So the strategy is I can make the bases the same. 125 is 5 cubed. Now that the bases are the same, I can just cancel them out. So I'm solving 2x plus 1 equals 3. And that's easy to solve. Finish. The second method is I observe it's an exponential equation. So I'm in exponential form, I can go to log form. So do that yourselves. So basically the guy all by himself gets the word log. The base on the other side becomes the base here, and the power drops down. And in case you've forgotten how to do this, you basically ask yourself, 5 to the power of what number gives you 125? And the answer is 3. Whoa, we come to the same spot. But we were approaching it in 2 different ways. Check if the final answer is 1. Okay. 11 is just formula review. See if you can pause the video and do this yourselves. So sine theta, in case you've forgotten, is y over r. Tan theta is y over x. Cosecant theta, cosecant is the reciprocal of sine, so that's r over y. Sec theta is, sec is a reciprocal of cos, so that's r over x. Cot theta, or cotangent theta, is the reciprocal of tan, so that's x over y. And finally, cos theta is x over r. Okay. Let's do 12 together. You can pause the video, attempt it yourselves. So in case you've forgotten it, first step, we'll convert this into degrees. Pi over 3 is 60 degrees. So 2 times pi over 3 is basically cos of 120 degrees. Which quadrant will 120 degrees be in? The correct answer is quadrant 2, because this is 0, that's 90. This is 180. That's pi over 3, 60 degrees. So this is a 60-degree reference angle, okay, automatically. So see if you can plot the sides of the triangle. So across from 60 is radical 3. Next to 60 is 1. Actually negative. Watch your signs, please. You're in the second quadrant. That's 2. And the absolute last step is write the formula. What's the cos formula? We just did it. It's x over r. So it's basically x, which is -1, over r, which is the hypotenuse, which is 2. Ta-da! So not too bad. Okay, but it requires you to know 30, 60, 90 triangles.